Welcome to MyProjectBazaar.com. Let me discuss about the process identification of stress arrhythmia from ECG signal. Let me see the abstract of the process identification of stress arrhythmia from ECG signal. Detection of cardiac diseases has much importance in saving people's life. For the identification of detects using ECG signal, feature values were extracted from the ECG signals. ECG signals were the basics for the detection of cardiac diseases. In this work, the novel method in the prediction of cardiac diseases is proposed. The obtained ECG signals were noisy due to the loss of some of the signal values due to the problems in the electrodes and the calculation on natural addition of noises in the signals. Initially, we filtered the noise with the help of wavelet transformation. The wavelet transform process decomposes the signal into several wavelets, and the wavelets were recombined in order to obtain the denoised signal. The denoised ECG signal is free of noises, and the performance is measured using the PSNR value. For extraction of features, we calculate mean, moment, skewness, standard deviation, variance, and kurtosis. These were all the statistical features extracted from the signals. The R peak values were detected from the signals, and those values were also combined along with the previously calculated features. The extracted features were selected based on genetic algorithm and PSO optimization process. The two performance of the two optimization processes were compared. The optimization process reduces the number of feature values extracted by selecting the best feature values from the extracted feature values. The classification of the abnormality is obtained with the help of SPM and PNN classifier. The classifier analyzes the feature values and identifies whether the input signal is normal or abnormal signal. Finally, the performance of the system is analyzed. The performance of the process is calculated with the help of accuracy, sensitivity, and specificity of the process. Let me see the flow of the process. First, the input ECG is obtained from the dataset. The pre-processing process is employed based on the wavelet transformation. ECG signals were pre-processed using WC's wavelet. Pre-processing is the process of removal of noise present in the ECG signal. By means of this, the performance of the processes was improved. The WC's wavelets are orthogonal wavelets defining a discrete wavelet transform characterized by maximum number of vanishing moments for some given support. With each wavelet type of this class, there is a scaling function which generates orthogonal multi-resolution analysis. With the help of this, we divide the coefficients into approximation coefficient and the decomposition coefficient. These were combined producing the denoised signal. After that, the features were extracted based on the statistical parameters from the ECG signal. For the extraction of the features, mean, moment, skewness, standard deviation, variance, and kurtosis, they were all calculated. Along with these features, the RR interval of the input denoised ECG signal is also measured. From the extracted features, best features were selected using PSO optimization process. In the PSO optimization process, the input feature values that were more optimal were selected from the extracted feature value. A basic variant of PSO algorithm works by having a population of the candidate solution. These particles are moved around in the search space according to few simple formulas. The movement of the particles are guided by their own best known position in the search space as well as the entire swarm's best known position. When improved positions are being discovered, this will then come to guide the movements of the swarm. The process is repeated by doing it till the satisfactory solution is identified. Similarly, for the comparison of the efficiency, genetic algorithm is also used. Comparing PSO algorithm, genetic algorithm is a existing method. In PSO only the accuracy will be improved. From the selected best features, then the classification process is done. So for the classification process, two classifiers are used: SVM classifier and the PNN classifier, and the performances of these two classifiers were measured. For both classifier, the decision is whether the input signal is normal or stress or signals. So from the values calculated, we measure the performance of the process based on accuracy, sensitivity, and the specificity of the classification process. Let me see the running procedure of the process. If you want to run the code, select the file main.m which is present in the source code folder. Right click it and click on run file in order to run the process. First, select any one of the input ECG signal. So we have different categories of the signals. So we can select any one of the ECG signals. So we select this signal as input, the process will goes on. First, this is the input ECG signal that we have selected. Next process is the pre-processing process. For that, the input signal is decomposed based on the wavelet transformation into approximation and the two coefficients. So after that process, we select any one of the coefficient for the decomposition process. So we select any one of the coefficient. After that, the feature extraction process and the classification process will execute. These the after this selection of the particular segment, the selected coefficient has been further divided into these four coefficients based on the wavelet transformation process. After that, the R peaks in the ECG signal is calculated. These are all the detected R peak values in the ECG. This is the feature values extracted from the input signal. So this is the features selected using genetic algorithm. So using genetic algorithm, we have selected the features. After this is the selected train feature and the test feature using genetic algorithm. This is the selected train feature and the test feature using particle swarm optimization process. So for genetic algorithm, this is the number of iterations taken, the population, and the final fitness value estimated. And for PCO optimization, this is the minimal fitness achieved. And finally, this is the classification. So classification using PNN and SPM with the features selected using genetic algorithm and the particle swarm optimization is displayed here. And finally, after that, we have measured the overall performance of the process. So the performance of the process is measured with the help of the accuracy, sensitivity, and the specificity of the process calculated for each process separately. So for classification using PNN and with optimization with genetic algorithm and PSO. Similarly for SPM. So like that we have calculated. Thus we have identified the disease in the ECG signal based on the features extracted from the signal, and we have measured the performance of the process. Thank you.